Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Guillermo Amaral joins me. We're going to be talking about a new open hardware video processing board. It's really cool. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Guillermo Amaral. Episode 359, recorded October 20th, 2015. Numato Opsis. This episode is brought to you by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code FLOSS in the billing section for a $10 credit. And by PagerDuty. PagerDuty decreases alerting noise for IT operations and developers to ensure that the right engineers are notified at the right time. Increase your uptime and sign up for a 14-day free trial at PagerDuty.com/twit. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at StoneAge.com, bringing you each week the movers, the shakers, the big projects, little projects, projects you may be using every day, not aware of it, projects you might want to download right after the show. You're not going to be able to download today's project, but you might want to look into it a little bit further. So I might as well bring on my co-host first before I tell you where I'm at, because it makes sense more that way. Guillermo Amaral, welcome back to the show.
Hey, Randall, how's it going?
Well, apparently I'm stumbling a little bit. Maybe it's a little too much tequila last week because I am here in wonderful, sunny Mexico, actually just, a couple miles from your place.
Yeah. I know exactly where you are. I can see you from here, actually.
Really? I'm waving? Can you see me waving? Okay, great. So,
hey, how's it going?
So the bandwidth is a little challenged here, so if I drop out occasionally, we will just write that off as the advances of technology. So we have a great guest on today, Tim Ansel. He's going to be talking to us about, let me get the name of this right, the Numato Opsis, which is an open hardware project. It was actually part of, or is still part of, Crowd Supply, which we had on a few weeks ago. It apparently does all sorts of wonderful things about video routing, video computing, HDMI and video display ports, got USB on it, got high-speed Ethernet, but it's basically an open hardware project that you can have for very cheap, not currently in production, but that's what they had the Crowd Supply thing to be able to start doing. What do you know about this so far?
Well, I saw this project on Crowd Supply when it actually was announced, and I do remember wanting one of these boards to play around with the FPGA on there. I know a little bit about it, but I guess we should probably let our guest do the talking more than we should.
Well, of course. I mean, that's the whole point of bringing it. That's the whole point of bringing a guest on, is that we can actually, instead of just making up what we can see based on the crowd site, based on the site, we can actually like talk to somebody for a little while, and I'm sure he'll have many wonderful things to talk about it. But before that, I have a very important announcement, because whether you're an experienced code warrior or just getting started, you need flexible, reliable, and affordable hosting. DigitalOcean provides developers with Droplets, which are virtual private servers that can be customized and deployed quickly to host websites, web apps, production applications, personal projects, virtual desktops, and almost anything else you can think of with full root access. I myself am a DigitalOcean subscriber. I've had a box there since February when I found out about them at scale, especially because they're running FreeBSD as one of their choices. That's really important to me because I love FreeBSD. Because DigitalOcean is built for developers and is used by over 400,000 of them, including me. You can deploy and configure your Droplets via a streamlined control panel or simple API. You can choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD, especially good for me. Servers have up to 20 CPUs, 64 gigs of RAM, and 640 gigs of SSD hard drive space. Highly scalable to meet the demands of a rapidly growing application or business. Auto backups and snapshots let you easily clone, deploy, and resize Droplets as you grow. Web console access with HTML5 plus SSH, SFTP, and KVM or VNC for virtual desktops. And it's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. DigitalOcean has incredibly affordable and straightforward pricing. Servers start at only $5 a month. There's also hourly pricing available starting at less than a penny per hour. But we're going to make it so you can get started today and deploy an SSD cloud server for free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code FLOSS for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do. That's DigitalOcean.com. And once you sign up, enter the code FLOSS in the billing section for a $10 credit. We thank DigitalOcean for their sponsorship of this show. And now let's go ahead and bring on our guest.
Hi, it's nice to be here.
Hey, great. Where are you speaking to us from?
I'm speaking to you from Sydney, Australia. It's currently like 10 past 2 in the morning. So it's pretty late, but pretty good.
Well, actually, you told me in some previous email that you're typically up at this time anyway. Are you a night owl?
Yes, I'm very much a night owl. I tend to go to bed in the larger hours of the morning rather than, the normal hours people seem to use. Pretty typical of computer people, right?
Yeah, whatever works for people. So I gave sort of, both Guillermo and I gave sort of our view of what we think this is about, but why don't you go ahead and tell us what this is and what problem it's solving? Okay,
well, the board is kind of part of a bigger scenario that we're trying to do, and that's the Teams Video Project wants to make it possible for every user group and every conference in the world to record and live stream their content. And to do that, you need hardware to actually capture that content, and that's where the Opsis board comes in. And the only way to do, make this scalable is really to be open and do open source. And so that's why we really want to do open source hardware and why all our software is open source and everything we do, we try and do open source.
Well, you think this is something that's been solved over and over again, though. What's unique about this Opsis board?
The openness is like the really big unique thing because to get similar type of functionality, you're looking at paying large amounts of money to somebody who is giving you the same type of hardware we're developing, but is got some proprietary firmware on there that's their kind of like secret sauce. And that secret sauce they charge, many tens of thousands of dollars for. And so once we knew that like the hardware isn't actually that expensive and we just need to replicate the functionality in software, it made sense that we should just, do that. Open source is great at this, right? Look at the Linux kernel. So yeah, that's kind of where we started off. We wanted to make this much easier available and much cheaper and do it all in open so that everybody else can contribute to it and help improve it. And I don't obviously have to explain open source to you. You're run a podcast on this. So yeah.
Well, you are using a term, though, that some of our audience might be unfamiliar with, and that's the idea of open source hardware. How is this? Yep. I mean, we're familiar with open source software. What does open source hardware mean?
So just like software, hardware designs have kind of a source to them. They have the schematics, which is basically the diagrams which show how all the integrated circuits in the board connect together. And then they have a thing called the PCB design, which is like the actual printed circuit board, the kind of in your computer, the green or sometimes the red or black these days board. There's kind of a, I guess in many ways, a picture of all the connections that connect up all the parts, and these are called traces. And so we basically publish all that information and all those designs under a Creative Commons share and share alike design license, so that you can take that board, and if you have the money, you can go and get a manufacturer pretty much anywhere in the world to make your version of this board. You can modify it, change the design, and then get them to make a version of it. As well, like when developing software, I don't know how many times people have said, I wish I knew how this thing works. Having the complete schematics and PCB design means that you can actually look at it and see how it's connected up and understand how the things work at kind of a high level, and even looking at the traces. Like if you think there's some type of mechanical issue in the board, you can go and look at it and see, have we accidentally connected two signals that weren't supposed to be connected, and is that what's causing your problem? So
what are
some of the software.
Sorry. What are some of the challenges facing video casting a conference? I mean, isn't it just a matter of like setting up a webcam and throwing it on Hangouts on Air and using that for your chat room? What's the challenges that this board helps solve?
So that's where everybody starts, going, this can't be a hard problem to solve, right?
Yeah, that's why I'm asking.
It's just, you just do something simple like Hangouts and then it's all solved. It turns out that the theory is much easier than the reality. And the big thing is we try and support open source conferences, and open source conferences are reasonably diverse in the type of equipment, the type of presentation tools, the type of content that is even available in a conference. Like I've seen presenters at open source conferences using Raspberry Pis. I've seen them use like standard MacBooks. I've seen them use their own hardware that they've designed themselves. So the idea that you can just like use a piece of software and make all the problems go away is pretty impossible. And like if you're a free software person, the software might not even run on your operating system, right? So our kind of solution to that is if the user can get the output onto a projector, why don't we just pretend to be a projector and sit in between the user's laptop and the projector, and then we can capture that raw content and provide basically a digital copy of that. And then as long as the person can get a output onto the screen, like at the venue, then we should be able to capture it. And it doesn't require any change from the presenter at all. They just do exactly what they would have normally done, and we get a copy of it. So that's kind of one of the things this board does. It basically sits in between the presenter and the projector and basically intercepts the signal. You can kind of think of it as a man-in-the-middle attack for your video capture.
And what's your relationship with Crowd Supply? How did that all get started?
So to make hardware, obviously, is a bit harder than making software. You can't just, upload the hardware to the web and have people use it. They actually need something that is physically made and sent to them. And so we were very interested in crowdfunding the board to get it into as many hands as people. Electronics is also very much the case that if you have a lot more boards, it gets cheaper. So crowdfunding is really well suited to doing things like hardware, things that are physical objects that get cheaper if you have more people supporting them. But, we're kind of open source, and that's like a really core part of our methodology and how we do things. And so when we were looking and evaluating crowdfunding sites like Kickstarter, Indiegogo, we came across Crowd Supply, and it just kind of made sense that this was a platform for us. It is a platform for open hardware, and we were very much interested in not just being another random Kickstarter, like building a community and being open at the core. So the kind of Crowd Supply idea that all these other projects have been open as well was really, really attractive to us.
So maybe you can clear this part up. You mentioned you have open source software, open source hardware. In this case, I already know the answer myself, but I would like to probably get into this a little bit. You have the board files, right? So are you just using the Gerber files? Are you just spreading those out, or do you actually have something maybe in I don't know, Eagle or Altium, or what are you using to actually design the board?
That's a great question, because this is a interesting problem in open hardware design, is that many open hardware just provides, say, the Gerber, which isn't all that useful if you want to modify it. And like one of the core principles of something like the GPL was that the reason it was open sourced was so that you could modify it for your own usage. So then the next step after that is that there are some commercial tools like Eagle and Altium that you can do, and you can share those files, but to actually make these modifications, you need to buy their software. And like Altium license is like $5,000 US, I believe. It's like a very expensive license. So because we want people to take this board and modify it and do cool things with it, we made the decision to use an open tool to do this. And the open tool we use is KiCad, and we publish the full design in the format KiCad expects. So you can use a completely open source tool that is KiCad to view and edit our designs and hopefully improve them. We'd love for people to contribute back and help make a second revision of the board even more awesome than our current board. Like, this is why we're doing it. We really believe in open source. Like, our designs aren't, soon to be published. They are published on GitHub right now. You can go and see all our issues we have with them, and you can see how we're trying to solve them, and you can download the GitHub repo and start modifying it using open source software.
I like that little stab you gave. I know a lot of projects, are soon to be open, right? And they promote themselves as open source hardware. They don't really release anything, or they might just release the Gerbers in this case, right? Which, as you mentioned, you really can't do much with them. But could you give us a little idea of what is on the board? What parts are there? What you can actually do with these parts, especially focusing on the FPGA and maybe the connectors and stuff like that?
Yep. So for your audience's information, an FPGA is a field programmable gate array, and the really interesting thing about a field programmable gate array is that in many ways it makes hardware problems software problems, and it basically allows you to build high-speed hardware using software, and then update the design as you go. So as we improve the design, you just download the new, what we call gateware, onto the board, and it can get new features, new functionality, that type of thing. And so that's kind of what FPGA gives us, and why we made some design decisions about how to do this board. So this board has 2 HDMI inputs and 2 HDMI outputs that are directly connected to the FPGA pins. This has a downside that they only run at, they don't do 1080p at 60 frames per second. Sadly, the pins don't toggle that fast. But it gives us actually complete control over the signal. We could have put an integrated circuit on there that does HDMI at a much higher bit rate. But the problem with that is they're very black box. You can't tell what's going on inside the FPGA and, inside the integrated circuit. Whereas with an FPGA, we have complete control over those signals, and we can effectively better diagnose what is going wrong in the signal. And for our use case, which is like a conference and a user group, which has a large number of exotic things going on, and I'm sure everybody's experienced the thing where the speaker gets up the front and is like, takes 10 minutes to get their presentation going before they can actually get going. We really want to make that a problem of the past. And the only way to do that is to have complete control over the video signal. And so that's kind of what this board is designed to do. It gives you complete control over the HDMI signals on these 2 inputs and 2 outputs at a very, very low level. And so, yeah, that's kind of one of the really cool things about this board, which the design is actually inspired by a design created by Bunny Huang, the Xbox hacker, who's also famous for the Novena laptop and a few other really cool open hardware things. He developed a project called the NETV, which is a device which allows you to overlay your content onto a HDMI stream. And that's the board that really kind of inspired us to create the Opsis and do a design where we have the complete control that we need in order to make these problems go away. Because once you have that control, you can figure out what's going wrong with the problem and solve it, instead of, you know, just going, I don't know. And yeah, we can improve it, and when people get the update, everybody gets an improved experience rather than having to wait the 5 years life cycle that a normal piece of hardware might have.
Is the software for the FPGA also open source? Like, I suppose it is, but I know there aren't really that many ways to compile this FPGA software, at least not free. Is the tool chain free from start to finish?
Sadly, that's one area where the practicality gets in the way. Sadly, like the full source code for the firmware is open source. You can go and it's on GitHub again, on our GitHub. You can go and have a look at our source code. But to compile it from the source code into the stuff that runs on the FPGA, you do need a proprietary closed source toolchain. That toolchain is available for free as in beer, but not sadly free as in source. This really makes me upset, and I would really like that to change. And there's some really cool people working on making that change, but at the moment, we're not there yet.
Yeah, I keep waiting for that day to happen. It's probably not going to happen soon, though.
Yeah, the Ice Storm guys recently demonstrated a full end-to-end, completely open source toolchain for a much simpler FPGA than is on the Opsis, but a end-to-end, no proprietary in any part of the system for a FPGA. So they're getting there, and I'm really excited about the work they're doing. And, you know, open source has this kind of network effect. The more people that are working on it, the more better it gets, and the faster it gets better. So that's the other thing I'd really like about the Opsis is the more people I can get the Opsis in the hands of, the more likely somebody who's smarter than myself is going to figure out how to do an open source toolchain for the board. And I'm really excited that people are really interested in doing this, and I definitely try and support them as much as possible in doing that.
So this little guy does a lot of HDMI, as you mentioned, right? So if I remember correctly, HDMI does use some sort of encryption when you're sending something, let's say, from your Blu-ray player over to your TV. Does the board handle the encryption well?
So in our use case, we don't deal with encrypted content at all because you know, they're projecting to an audience, so they shouldn't be, you know, doing the encrypted content. So our current firmware basically just advertises itself as not supporting the encryption. So devices won't try and send encrypted content to that. The interesting thing is that the NETV device that Bunny created, which has a similar FPGA as the same series of FPGAs, it's a much smaller one than the one we have, does do encryption. So in theory, all that was required is for somebody to port the NETV encryption stuff to the Opsis board, and we could do encryption. It just hasn't been a high priority for our use case because, yeah, we don't deal with encrypted content really at all in conferences or user groups. But yeah, I would be very interested to see somebody take on that project, and it wouldn't actually be a huge project because, as I said, Bunny uses a Spartan 6 LX9, and we use a Spartan 6 LX45, and the last number is just kind of how many resources are available on the FPGA. So they're very, very similar in terms of structure, and it will be trivial to port the code between the two devices.
So at the risk of making our software audience's head blow, could you probably give us a little idea of how hard it was to actually, you know, go through the manufacturing process for this little board?
So it's been a long process, but a lot of the length of the process is because this is a hobby project for me. I have a full-time job, and this is what I do for fun in the my spare time. So a lot of the reasons it's taken so long is that hardware often benefits from taking a continued stab at it for, say, 8 hours straight, because hardware, like when you set up, there's a lot of just cables to connect up. It's not like, you can just sit down at your computer while you're on the train and start hacking. To do hardware and to debug hardware, you need to get out your, board, connect it up with probes and these type of things. So when you're not doing it as a full-time job, that can be quite hard to find an 8-hour block to just sit down and do that development. Other than that, it's not really that hard. It's just slow because everything takes weeks to do. When you get a PCB manufactured, it's like a fast turnaround is like 3 days. Imagine if you were trying to develop code and when you hit compile, you walk away for 3 days and come back with a result 3 days later. That is the type of workflow that hardware has. So you spend a lot of time trying to check things before you send it off to manufacturing, because if you actually want to do it for a reasonable price, not for, thousands of dollars for fast turnaround PCB, you're talking 4 weeks for a PCB to get back to you. So imagine doing another compile and getting the result back 4 weeks later. That's kind of the big reason hardware takes so long and why hardware, I guess, is so much harder than software. Like, simply, it's basically just drawing lines between A and B and knowing that that line is okay. That needs a little bit of knowledge, but it's not beyond anybody who's done a Ruby on Rails web app. That is requires significantly more knowledge of moving parts and, 10 different technologies than doing something in hardware. I think that's kind of a really interesting thing. As well, the tooling is very unsophisticated. The idea of when you commit, you run checks is not something that really happens in hardware these days. And it's something that, as like my full-time day job as a software developer, I find really hard to deal with is the idea that, the idea of unit testing doesn't really occur much in hardware. Like, and all these things, like everything you do on these boards could very much be checked by a computer much better than, yeah, as it's 2 a.m. here, the lights have decided to turn off. I'll have to wave my hands in a minute.
All right.
Just to finish what I was saying is like all the things I was talking about, like HDMI and stuff like that, making sure you connect the high-speed signals to high-speed FPGA pins. A computer is much better at checking that than a human is, right? But that doesn't, we don't have tools that do that. So that's something I've been trying to improve. But, I've only got so much time.
Yes. So I love your use of the word compiling there. I got distracted by the other jokes that I was doing in the chat room. Because I remember the XKCD comic strip, I'm sure you've seen this. It has, what are you doing out there fighting with swords? Well, compiling, it takes time. I didn't realize it was that much worse on hardware. But I also want to know, what's the status of this? Is this something I could buy today and use today?
Yes. So The way we started development is with a basically off-the-shelf prototyping board. So that board's called the Digilant Atlas, and it's made by a company called Digilant, which basically do a wide range from like really cheap to super expensive, like $8,000 dev boards. So we found the boards that kind of fit the criteria that we were after, that wasn't too expensive, and started with developing the firmware for that board. And we have a working firmware that runs on that board, and once we'd gotten to that stage was when we decided it was time to launch our own hardware, because the prototyping board is designed, A, it's not open, and we want it open, and B, it's designed to be a good prototyping board. So it has a lot of features that we don't need in our use case. Things like a lot of switches and audio and things like that. So it drives the cost up, obviously, having those extra features. So once we had working thing, we wanted to support multiple boards and support our own board. And so now we have firmware that works on both boards. I have basically the first Opsis that was ever made was shipped to me, and I've been working on getting the firmware, working on that. We have 8 other people around the world who have Opsis boards that have been working on making sure the firmware works well and reliably. It's still a little bit on the work in progress, but definitely by the time the hardware ships, it will be like absolutely rock solid. So like we plan to ship the first batch of boards in December. So that kind of gives you an idea of how close we are to having this all working and having this capture stuff work. If you go and look at my YouTube channel, I actually have 2 tests that I've done recently using our firmware on a Atlas board, not an Opsis board, capturing a couple of presentations I've been giving about the firmware at the local user group that I was, local user groups I've been attending, like the Python user group and the WebRTC user group. So yeah, it definitely works well enough to record a 45-minute user group. We have a guy in the US who used boards for doing conference capturing at PyCon in South Africa, and was very successful in doing the capture for that conference using our boards. So we're really starting to use it in production now. And yeah, if you go to Crowd Supply, you can order one. And like often crowdfunding campaigns, you're going to get the board, 2 years after the crowdfunding finishes. You're not in our case. We're targeting kind of end of December for the first batch of boards to be sent out. And the reason we can kind of do that is because we had this very good prototyping boards that we were able to get 95% of the way there before we had to commit to do it. And I think that's really why, as well, crowd supply was a much better fit to us than something like Kickstarter. Because, as you, Josh said on your podcast a couple of weeks ago, is crowd supply positions itself as a storefront, not as a investment platform or angel platform that Kickstarter kind of says, no, we're not a storefront. When you're doing a Kickstarter, you're not actually buying a thing. You're kind of buying the hope of getting a thing in the future. Whereas crowd supply says, like, no, when you back something, you expect to receive it. And, like, that was a great fit for us, and why we went with crowd supply in the end.
I'm curious. I love the fact that you keep redefining or emphasizing what crowd supply is about. That's really cool. I'm more curious about the practical aspects of this, because I speak at a lot of conferences, and I know there's always seems to be some sort of difficulty, especially with laptops running Linux for some reason, to get it to talk to the projector or get it to talk to the recording device or whatever. Does this thing sort of out of the box work well with Linux laptops? And what configurations does it come with? Can it present itself as a USB camera for my broadcasting software? Or
Yep.
Give me the practical. What does this look like to the laptop? What does it look like to the presenter software?
So, to the presenter, it looks like a projector. The presenter, and it looks like a projector which gives you one choice of resolution that you can select. So, I'm sure you've been at a conference, and when you're presenting, the first question you always ask is like, what resolution do I use? Like, I've got this drop down, and they're like 30 resolutions that I can pick from. Which one's the right one? And then you pick one that's always the wrong one. This is like a super simple problem to solve. You should only present one option. It's hard to get one option wrong.
Yes.
And so out of the box, the board only presents one option to the presenter. It says to the presenter's laptop, I support this resolution and nothing else. So that reduces a huge amount of complexity in just getting the right resolution selected, which is a problem a lot of Linux laptops have, is getting it to output the right resolution can be quite hard, because it always wants to output the resolution of your laptop screen, which is not necessarily in any way related to the resolution of the projector output. So that's one way it helps with that. Another way it helps from running the AV at a conference is the device appears as both a webcam and a serial port. It's not expected that you connect the Opsis to the presenter's laptop. The Opsis for capture, the Opsis is connected to a capture computer, which is separate from the presenter's laptop. And so that capture computer is connected through the USB to the Opsis. That capture computer sees two devices that the Opsis provides. One of them is a USB webcam, and the other one is a USB serial port. And USB webcam just looks like any other webcam on the planet, and it uses a standard called UVC, which a majority of decent webcams support, which means it has driverless operation under under Linux and Mac. You just plug it in and you get a video device. On Windows, it's not quite that easy. You need a ini file. You don't need any drivers. You just need an ini file to tell Windows that this is a capture device. You don't need any software or anything provided by us. You just need any of your standard video capture software like Skype or Google Hangouts or whatever else you want to use. Like you could use MPlayer on a Linux laptop to do capture, or GStreamer or anything like this, because it just appears like any other webcam. The computer doesn't know it's actually a stream from a HDMI man-in-the-middle attack, effectively. But the other thing, it appears as a serial port. And the reason we appear as a serial port is because we can connect to the serial port and get debugging information about what's going on with the HDMI signal. Something as simple as when a presenter plugs in their laptop, the idea is that we get a message on the serial port saying new device plugged into port A. Or like when it's disconnected, we get a message that, device disconnected from a port A. So one of the big problems in conference things is that you have lots of cables running everywhere. If the presenter plugs into the wrong cable, you want to know that. And so having these debug messages means that we can monitor that as AV crew and go, no, the presenter hasn't plugged in their laptop yet, or some person has just decided that their laptop is more important than the presenter's laptop and disconnected the cable running past their computer. And things like that. We can get notifications about this rather than the screen just going black and us going, what's going on? Why hasn't it worked? And we can see information like what resolution the presenter is actually sending. If they somehow manage to send a resolution that is not on the list, which on Linux is actually possible to do. It's much harder to do on other operating systems, but you can still manage to do it when things go bad. We can see the resolution the presenter's sending and can go, no, the resolution you're sending is not the correct resolution, rather than having to guess. And we can do this programmatically. We can have software that says to the AV guy who might be a volunteer who is, had a day worth of training on how to run the AV gear, to them, the reason the video isn't working is because the presenter is sending the wrong resolution. We can present that information to the AV guy or AV girl. And so, as I said, at the beginning, our goal is to make every user group and every conference recorded and live streamed. And the only way we can do that is if it doesn't require a person who understands AV to be involved in the situation. And the only way to do that is to have hardware that we can debug programmatically and that we can really control and understand what's going on. We can't have any black boxes in the system. And
Absolutely.
Proprietary systems are black boxes.
Yes. Yeah. I want one of these now. I really want one of these. It would solve so many problems I've had at conferences before. We're almost out of time. I know Guillermo's biting at the chomp for a couple of questions. He still wants to get in on the show, but I have an important announcement before we do that, because PagerDuty is an operations performance platform that delivers visibility and actionable intelligence to help increase the uptime of your apps, servers, websites, and databases. If you rely on your software and services to always be up, PagerDuty is an essential tool. As the hub of your operations, PagerDuty connects all of your systems into a single view where you can see critical events across all your monitoring tools. If alerts are missed, PagerDuty will automatically escalate issues to another team member until it's responded to. You can also decrease the noise. Incidents are automatically filtered and deduplicated to ensure only actionable alerts are delivered. PagerDuty's analytics tools will also identify common problems, allowing you to proactively make system improvements and prevent future outages. You can customize it to fit how you and your team work, regardless of location or size. PagerDuty is trusted by thousands of companies, including Microsoft, GitHub, Boeing, Nike, Pinterest, and Box, and my two clients as well. So we all rely on PagerDuty to make sure that happens. So get the right engineer on the right problem at the right time. Visit PagerDuty.com/twit to sign up for a free 14-day trial. And for as little as $19 a month, you can increase your uptime with PagerDuty. And when you sign up for a new account, you'll also get a free t-shirt. That's PagerDuty.com/twit. And we thank PagerDuty for their support of Floss Weekly and other shows on this network. Guillermo, you had a question?
Yeah. Actually, I've noticed that John's getting super excited about this board, and I did want to at least get this in there so people can, know if this board is right for them. Well, besides just playing around with something, you should always play around with hardware if you're not familiar with it already. But is this? Are you able to do any mixing? Could you do a lower third as the one you see below me now? This beautiful thing right here, or maybe do something like picture-in-picture with this?
So the answer to that question is complicated, but the short answer is at the moment, no, but it is something we would love to add, and it is definitely well within the capabilities of the hardware. The hardware can do mixing, it can do scaling, it could do something like this lower third without significant problems at all. It's just we need to finish the software to do that. And we do, as I said, there are two HDMI inputs. We can do, at the moment, hard switching between the two inputs, and that is totally transparent to both the projector output and the webcam. So if you just need switching, we've already got you covered. But if you want to do actual, nice crossfades with, like fading out and fading in, that's just something we haven't yet implemented. I have a design for how to do it, and we're 100% certain we can do it on the board. You can buy commercial proprietary what are called cores, which is kind of FPGA speak for like software module, which do this. And that work on the Opsis. So, if we were cheating, we could just, buy one of these cores and run it on the Opsis, but that's kind of black box, not what we want to do. So we want a fully open version of those cores, which kind of sucks for them because they won't be able to sell it anymore, because that will have a free version of what they make their money off, which anybody can use under a BSD license. So anybody can use it in any way. But yeah, we're just not at the stage of being able to do hardware mixing yet. But as a famous last words, it's just a software problem. It's not a hard problem to solve. We know how to solve it, and we would love people to help us solve it. And honestly, it's not like people get scared off by the fact this is HDMI and this is high-speed signals, like that we're talking gigabits per second that we're operating at. But all these operations turn out to be very simple things to do, right? Like downscaling is pretty much, you add the pixels together and then you divide it to get an average, right? If you can understand that concept, you could probably implement it in hardware. And it there's a bunch of complexities about how to do that efficiently, but it's not a super hard problem to solve, and it's something that anybody, I am sure, who can write software can do hardware. It's not a secret that nobody can do, and only people with certain experience can. And there are great tutorials out there. Like we live in the world of find your solution on Stack Exchange. That is just as true for FPGA hardware problems these days as well.
So is there any reason why you went with the Spartan 6 instead of the Spartan 7? Would that come in handy when you need to do these sort of, just software issues?
So I think you mean the Series 7.
Series 7, yeah, of course, yes.
Basically, the reason is because we've been developing this board for a long time. It's been a long time coming, and our prototyping platform is a Spartan 6. The device that inspired us, the NATV, is a Spartan 6. And with hardware, because making changes is fairly high risk. If you get them wrong, you're waiting a long time to fix them. We decided the big risk we were going to take on with the Opsis board was adding high-speed transceivers to the board, which means we decided to stay with the older generation FPGA, but go with the high-speed transceiver part, which actually means that on the two DisplayPort connectors we have there, we can do 4K video. And we recently had a pretty amazing success in that one of our good friends, Mike Hamsterfield, who is in New Zealand and has like a huge amount of great FPGA resources. I'll give Randall the link so that he can put it in wherever this is published. Developed a fully open source DisplayPort core running on our Opsis board, doing 4K video output at 30 frames per second on our FPGA board, which we're super excited about. I think it's pretty much a first for the open source world to have 4K video coming out of an open source DisplayPort core running on fully open source hardware. So we're pretty proud of that achievement, and that was kind of the big risk we took with doing the Opsis board. If we were ever to do a V2 version of the board, we would probably use a Series 7 FPGA. It just makes everything slightly easier. For the mixing stuff, the mixing is well within the reach of the Spartan 6. The mixing of 4K video is where it starts to get a bit dicey, and where the Series 7 with improved speed and resources, because it kind of uses a newer, smaller fabrication thing, and as everybody kind of knows, as fabrication technology improves, your CPUs improve. That's kind of the same with FPGAs. So yeah, if we ever do another board, which I think with the response we've gotten in our crowdfunding campaign is pretty likely, we will definitely look at doing a Series 7 based system. And the other thing is, because of the way our software works, our firmware, our gateway for the FPGA works, we've been collaborating with a group called that make the software called M Labs, and they have most of the stuff already working on Series 7 boards. So they use it for doing really cool science experiments like quantum computing and that type of thing. We share a lot of things with them, and they've done a lot of the work for us if we need to move to a Series 7 FPGA, which we're very interested in doing.
Very cool. Excuse me, we're almost out of time. In fact, I think we're right up against the time limit, but is there anything, any short thing that you can still say that we haven't covered yet?
Everything we do, we try and put in a hub. We would love your help. Even if you're a student who has the free time to work on this, but doesn't have the funds to buy a board, start contributing, and we will find a way for you to get the board. As well, I send people free T-shirts. Everybody loves T-shirts in the open source world, and I try and get a nice polo shirt rather than a kind of T-shirt like everybody else has. And I'm quite liberal at sending T-shirts. Send us a pull request, and I will try and get you a T-shirt. So yeah, we're open source. We want a community. We don't want to make money. We want to make videos and make awesome videos and want to get your content onto the web and available for everyone else to see.
Well, Tim, I appreciate you staying up till 2 a.m. to now almost 3 a.m. must be to be on this show. It's quite courageous. Although you said, I guess you're typically up this late, but I want one of these now. I'll probably go purchase one right away. Actually, I know you made a sale during this show already, so I know it's already working out. So thank you for coming on and talking about your work with open hardware and video and stuff.
I'll see now, and if anybody has questions for me that we didn't answer, I'll try and get you the information for probably, say, the next 15, 20 minutes. Then I should probably go home and go to bed.
Yeah, very good. Tim, that was Tim Ansel talking to us about this wonderful video project which just scrolled out of my screen. It's something called Numato Opsis. Okay, there we go. Hey, Guillermo, what do you think?
Well, I already liked this project before. And you know me, I like open hardware and all this hardware stuff, which is this is my thing, if you will. So it's fun having something like this on the show, and me being here to actually, be on it and talk about it, which is great.
Yeah, very cool. Yeah, like I said, I think this solves problems that needed solving, and now in a completely open source way, as open as it possibly can be. Too bad about that tool chain thing, but I'm sure they're going to work on that and get that going. And if you like this sort of thing, which Guillermo, I know you do, and I know some of our audience definitely gets excited about this stuff. Next week we have another crowd supply project just signed on called Snickerdoodle, which is a Raspberry Pi and Wi-Fi for robots. Very cool. Following that is OpenSense, which is a FreeBSD-based firewall. Dart, the programming language Dart. Casper Lund, who's one of the leaders of the Dart project, is going to be coming on the show to talk about where Dart has gone over the last couple of years. We've also got Caddy, which is high-performance web server written in Go. We have Kinoma, which is just added to the show. Kinoma is advanced JavaScript for the Internet of Things. So lots of shows coming up. We'll be talking more about those as they go by. If you want to find out what's going on, go to twit.tv/floss. That is going to be the homepage for this show. We have our list of guests there. Always look for more guests. If they're not on that list, please have the project leader email me, merlin@stoneninja.com. We have a live stream. We took a couple questions from there. We're typically on 8 a.m. Pacific time, now on Tuesdays. We've moved to earlier in the week. You can follow us at Floss Weekly on Google+. It's also automatically tweeted to Floss Weekly on Twitter. You can follow me at Randall L. Schwartz on Google+. That's also retweeted to Merlin, M-E-R-L-Y-N, on Twitter. I don't have anything to plug right now. Guillermo, you got something to plug?
Well, I guess people can follow me on Twitter, which is GAMARAL. I also have a YouTube channel with a lot of videos. Recently, I posted my trip to Japan on there. And soon I'll have a Minecraft Let's Play thing while reviewing the Pebble watch here, the new Pebble Time. So I guess that's really it. You can just Google for me, Guillermo Merlin, and I'll show up. I'm like the first 3 results.
Very good. Well, thank you for joining me once again on a South of the Border show, and we'll see you all again next week on FLOSS Weekly.